and we are here to help you how to solve an LP problem using Simplex method.
This method is a standard technique in linear programming for solving an optimization problem. Typically, one involving a function and several constraints expressed as inequalities. The inequalities define a polynomial region, and the solution is typically at one of the vertices. The Simplex method is a systematic procedure for testing the vertices as possible solutions.
Given the objective function and constraints, we will transform these into standard form. We have to consider the inequalities of every constraint. For this problem, all constraints are less than or equal to constraints. Therefore, we add slack variables to each equation. The complete set of constraints and objective function can now be expressed as follows. In formulating the initial tableau, fill out all coefficients of decision variables. The upper part are the coefficients of the objective function, and under the solution mix are the basic variables. We are now going to solve for the ZJ values. The numbers in the ZJ row are computed by multiplying the column on the far left of the tableau and the corresponding numbers in each other column. For example, here, 0 times 3 plus 0 times 9 plus 0 times 2 is equal to 0. To formulate the new tableau, we have to find the pivot column. The pivot column is the largest number among the Cj minus Dj values. So in this problem, our largest value is 90. So this will now become your pivot column. Next, we have to find the pivot row. To find pivot row, divide the quantity column with the corresponding values in the pivot column. So 66 divided by 3 is 22. 66 divided by 9 is 20. 200 divided by 2 is 100. Now we have to choose the smallest among these values. In this part, we have to choose 20 since this is the smallest values among them. This will now become your PR or your pivot row. Finally, we have to find the pivot number. The pivot number is the intersection of pivot column and the pivot row. This is your pivot number. Now that we have decided which variable is to enter the solution mix, the next step involves computing a replacement for the pivot row. This is done by dividing every number in the pivot row by the pivot number. 9 divided by 9 is 1. 4 divided by 9 is 4 over 9, and so on. We get this value by getting the number in old row minus the number above the pivot number times the corresponding number in the new row. The rest follows. Getting the values in S3 row, we have to take into consideration the number below the pivot number. So 2 minus 2 times 1 is 0. Then the rest follows. For the second tableau, this is the PC, the pivot column, and this is the PR, the pivot row. And this is now your PN or your pivot number. You know that we have obtained the optimal solution if the Zj minus Dj values are all 0 or negative values. But in this tableau, we still have a positive number, which means we have not yet attained the optimal solution. Therefore, we have to formulate another tableau until we get a 0 and negative values for Cj minus Zj. This is now your third tableau. And after that, we have reached the fourth tableau. So in this, we have seen that the values in Cj minus Zj are already in zeros and in negative values. Therefore, we have achieved our optimal solution. The optimal solution is x is equals to 10, y is equals to 18, and z is equals to 2,250.
For the second example, we have here a minimization problem. The objective here is to solve for the optimal solution using Simplex method. So we have here the LP model for the problem. For the revised model, it was mentioned that you need to consider the inequality sign of every constraint. So what we have here is greater than or equal to, which means that every constraint contains surplus and artificial variables. This is now the revised model. One of the difference between minimization and maximization problem is that you choose the highest negative value in Cj minus Zj for the pivot column. In here, the highest negative is this one. This will become our pivot column. And for the pivot row, we have here the quantity which is divided into the number located in the pivot column. So what you have here is 150 divided by 30 is 5. And in these values, you need to choose the smallest number for the PR, or the pivot row. So this will become our pivot row. And the intersection between the pivot row and the pivot column is what is our pivot number. You know that you have achieved the optimal solution for the minimization problem when the values of your ZJs are all positive and zeros. If not, formulate another tableau. This will be our second tableau. Our third tableau we have here, which is not yet optimized. This will be our last tableau since we have already achieved all positive and zeros in our Cj minus Zj values, thus it is already optimized. The optimal solution for this problem we have here is x, which is equal to 3.75, y, which is equal to 0.75, and the number of quantity, which is 46.5.